Student, today we will learn the chapter Limits and Derivatives. Students, these chapters belong to topic calculus. So first I will introduce you what is the calculus. You have calculus is divided into two parts: differential calculus and integral part. What do you mean by calculus, differential and integrations? Let this as we described about this, that this infinite point, and using this infinite point you have make a circle. Okay, when you used this very small part, very small arc, this one is a very small, it near about tends towards 0, means it is very small value, then we will describe this in the differential part of calculus. Okay, now if you integrate means large means small part plus small part, when you add it, and you can take it a sum of a large part, sum. This sum can be letter using by s. This s letter can be write this way. So integration can be defined by this symbol, and differential defined by delta x, means difference of two parts, that is tends towards 0. So if we want to be describe about a circle, first we have to study it about the small part that we will in differential, and again, and when we integrate the sum of small part, and it may be whole part, it may be sum, then this is known as integral. So differential and integrations are related to each other. Okay, so first in calculus we will go to the whole part about the differentials. In differential we will study it starting about the limit and derivatives and application of derivatives. Okay student, then after understanding the limit and derivative and application of derivatives, we will go to the integrations. Integration is just near about the opposite of, you can say it, differential. Okay, this is the most important to be introduced to you about the calculus. And about this calculus, Sir Isaac Newton has described us first. Okay, so student, now I am going to tell you about the topics limit and derivatives. Okay student, so now the word comes here, limit. This we have to understand the meaning of the limit, as by words you can imagine the meaning of limit. Okay. Now students, let I have a graph of here is the graph of fx equal to x square, and we want to draw the graph of this square. putting some values here and we get the value of y, and plotting on this graph we will find this type of the graph. Let here is a value of 4 and we get here the point is 4, 16, and similarly minus 4, then we get it here minus 4, 16, and simply we can calculate so many points, and at 0 x equal to 0 we will find 0, and near about 0 almost we will find the 0. Let x equal to 0.1, then y equal to 0.1 square equal to 0.01, and let x equal to tends towards 0, let here is 0, 1, then we get y equal to 0.01 square equal to 0.001, and you can see here almost when x equal to 0 it's always tends towards 0, isn't it? So it is a limit. Okay, so student, according to the graph we can say if we can find the value of this function at x equal tends towards 0, we can calculate here directly putting here 0 equal to 0. So this is known as true limit. True limit. This arrow tells the limit x tends towards 0. X tends towards 0. This arrow reads as tends towards. Okay student, so now I am going to tell you some more about this, that if you finding somewhere some values directly putting the value of x, then that is the true limit. For more examples we can calculate here. Let here is a question here, fx equal to x plus 2, and find x, the value of x tends towards 2. If we putting this value here directly, we can find here 2 plus 2 is equal to 4. It means if we find the graph of this line, then at 2 we will find the value 2, and this point will be on the graph. Okay, so if we put here 0, then we can find 2. So this way plot can be here. So you can find a point on the graph here. 2, x equal to 2, then y equal to 4. So you are finding here a point just on the graph, that is why we can say it is 4 is a true limit. 4 is true limit. Okay, now take another questions here. If fx equal to x square minus 4 upon x minus 2, and we want to find the limit x tends towards 2. What we can see here, if we put here directly value of 2 here, so we can see here 2 square minus 4 upon 2 minus 2, 0 upon 0, and that is undetermined. It is indeterminate value or undefined. Indeterminate value. Indeterminate value, so we cannot find the value of here any limit, so it is indeterminate 0 upon 0, hence we cannot say here is a true limit. So there are so many types of indeterminate values, that is 0 upon 0, 0 into infinite, 0 to the power infinite, infinite upon infinite, and so on. These are the undetermined values which cannot solve. So at this way how we will can find the limit. Okay, so let's again the same examples. If we want to find this limit and we cannot find directly as it is in determined form, so if we factorize first here, and then cancel out this factors which gives the undetermined values. Now putting here limit directly, now we can say we can find the limit. So here 2 plus 2 is equal to 4. So now we are finding a limit here 4. So it is only a limit, it is not a true limit, but it is a limit. On the graph, it means on the graph of these functions, let here is a function at 2, value of 2, we cannot find a point. We cannot find a point here. So if we don't want to be factorize it, we want to be calculate it. So how we can calculate? X square minus 4 upon x minus 2, x tends towards 2. X tends towards 2. So let here is a curve of this point, and we want to find at x equal to 2, and we cannot finding here directly x equal to 2, that is at x equal to 2 it is undetermined. So we can put just right side some value and just left side some value near to this and finding these values. Just we can find here 2 point near, just near is 2.00001, and left side we can find 1.99, and putting this value we find the some value is here, it is near about 4, and it is also near about 4. By calculation we can see, if we take the left side and take the right side some little bit value and some small difference, it is just near about 4. You can calculate yourself. Okay, so using this point we can say this is near about 4, and hence by calculation method it is equal to near about 4. So we can find the limit. Okay, student, it is just near about. So we can say we can find the limit by calculations. But it is a very tough method. By calculation we are finding this limit, but it is a very tough method. So to easy it, we can calculate so many things. Okay, so in which we first have find a common factor as before I have calculated it, then cancel out the common factors and then put the values, then we can find the values of limit. So we can say this things also, fx equal to x square minus 4 upon x minus 2, it will be described if f equal not 2. Okay, if it is not if it will be not described at x equal to 2, right? So x equal not 2, it can be described in the graph paper. You can find the value of except x equal not 2, right? So student, we can say as I have already told here, near about just right side and just left side, that at a x equal to a we have to find, and just right side we take a little bit value h, let that is delta x, and right side also h, that is delta x. So we can find if f a plus h, if we are given to find the limit fx x tends towards a, and we are finding here a plus h, h tends towards now 0. It is right side. Okay, if we find here f a minus h, h tends towards 0, it is left side, so it is known as left hand limit, and it is known as right hand limit. Now solving this, we can find the right hand limit and this left hand limit. Okay student, so using these two formulas, if we can also write this f plus fx x tends towards a plus means RHL. If we write here fx x tends towards a minus means LHL. Okay, so RHL and LHL also can be find out if we directly not find out the limit. So if anywhere RHL equal to LHL, then we can say limit is existing. And also if RHL equal to LHL and equal to FA, then we can say at x equal to a, function is continuous. Since we can find x equal to a, function is continuous. Okay students, so RHL and LHL can be tells us that when it is equal, that we can say limit exists, and if also it is equal to FA, then we can say function is also continuous. So student, how we will find the limit? So there are so many processes. One is the calculation method, and second also you can see here in this way that we can find RHL and LHL. So student, using this topic, I will describe you how we will find the limit using some basic formulas and using RHL, LHL also, and using factors method. So in the next top part, I am going to be describe you. It is a part 1 and I will describe you in the part 2, next part, about some basic formula. So thanks for watching.